Hi, today we are going over section 2.2, which is adding and subtracting radical expressions. Now, rules for adding and subtracting radicals are similar to those of variables. With radicals, we need to make sure that we have the same values inside the radical in order to add what's in front, just like with variables, we need the same variable to add the coefficients in front. So for example, dealing with variables, if you had 3x plus 4x, you would just add the two coefficients in front of our x's, giving us 7x. Very similar with radicals. If we have the same root, so we have root 2 for both ways, we just add what's in front. So that would be 7 root of 2. So we do not add what's inside the radicals. We just add the coefficients in front, and they need to have the same radical. Now here's another one with variables. So once again, with variables, we had to add like terms. So we'd have to add our x's together and our y's together. So 3x plus 6x is 9x. And then 2y minus 4y would be negative 2y. We'll do the same thing with our radicals. So we can only combine our root 2's, and then we can combine our root 3's together. So we have 3 root 2 plus 6 root 2. So that gives us 9 root 2. And then we've got 2 root 3 minus 4 root 3. So minus 2 root 3. So once again, can only combine radicals that have the same values inside the roots. It also has to have the same index. So if you had the square root of 3 and the cube root of 3, you would not be able to add or subtract those. Now, in some cases, we have to simplify radicals before combining terms. So in this case, I've got the cube root of 24 minus the cube root of 192 minus the cube root of 375. So at first glance, it doesn't look like we can combine them, but if we can change them into mixed radicals with the same value inside, then we can combine them. So I'm going to start by factor treeing 24. 24 is the same as 2 times 12. 12 is 2 times 6, which is 2 times 3. So it's a cube root, so I'm looking for groups of 3 identical terms. So that gives me 3 2. So this cube root of 24 gets replaced with 2 cube root of 3. Next, we have 192. So that's 2 times 96. 96 is 2 times 48. 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So I have one group of 2's here, another group of 2's here. So we'd have 2 times 2 is 4. So we have minus 4 cube root of, we had a 3 remaining. Lastly, we have our 375. 375 is the same as 3 times 125. 125 is 5 times 25. 25 is 5 times 5. So that gives me a 5. So I have minus 5 cube root of, I had a 3 remaining. Now all of these have cube root 3, so we can combine our coefficients. So we have 2 minus 4 is negative 2. Minus 5 is negative 7. So we have minus 7 cube root of 3. Next, we have square root of 63 plus the square root of 40 minus square root of 90 minus the square root of 28. Okay, so once again, we will have to change these into mixed radicals and see what we can combine together. So 63 is 3 times 21. 21 is 3 times 7. So we have a pair of 3. So a 3 will come out. So we have 3 square root of 7. Then we'll deal with our 40. So 40 is the same as 2 times 20, which is 2 times 10, which is 2 times 5. So we have a pair of 2's that can come out. So we have plus 2 root of, we had 2 and 5 remaining, so that's 10. Next, we'll do it for 90. 90 is the same as 3 times 30, which is 3 times 10. So we have a pair of 3's, so minus 3 root of 10. And then we have 28. 28 is the same as 2 times 14, which is 2 times 7. So I have minus 2 root 7. So we can combine our root 7's together. So 3 root 7 minus 2 root 7 is root 7. Then 2 root 10 minus 3 root 10 is minus root 10. And that will be as simplified as we can get. Now, if we're adding or subtracting radicals with variables, we also have to define a value for which the variable works, because once again, we cannot have a negative value in an even indexed root. So for example, identify the values of the variables for which each radical is defined and simplified. Now looking at this, in this one, we've got a squared in here. We know a is all real numbers because it is squared. So no matter what value it is, it's never going to make this equal 0. Our b, however, if it's negative, will make this whole thing negative. So therefore, b has to be equal or greater than 0. And we have the same variables here. So we have the same restrictions for this one. Okay, so now we'll go through and simplify this. So 50 is the same as 2 times 25, which is 5 times 5. And then a squared is a times a. And then b we can't break down. So we've got 5a square root of, we had 2 remaining and a b remaining. For the second part, we have 8. That's 2 times 4, which is 2 times 2. So we can take a pair of 2's out. So we have minus 2. We have a squared again, so we know we can take an a out. Square root of 2b. And we can combine what's here. So 5a minus 2a is 3a root of 2b. Next example, we have a cube root of 27p cubed q plus 8p cubed q. Now with this, for cube root, so we know that p and q are both all real numbers, because whenever it's an odd index root, it's going to be all real numbers. We have no restrictions. Okay, so we'll go through and start simplifying this. So we've got 27 is the same as 3 times 9, which is 3 times 3. So we know we can take a 3 out. P cubed is the same as p times p squared. P squared is p times p. So we can take a p out. So for this first one, we have 3p cube root of q. For next one, we have 8. That's the same as 2 times 4, which is 2 times 2. We have 3 2's, so we can take a 2 out. We have the same p cubed as we did in the previous one, so we can take a p out. And then we have the cube root of q. We can add what's in front. So we have 5p cube root of q. Okay, so practice for this section is on page 106.